second column, it should be known already, because that's been the last 2 days, and I said you had you memorized. Derivative of cosine, derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, derivative of secant is secant tangent, derivative of cosecant is negative cosecant cotangent, derivative of cotangent is cosecant negative cosecant squared. Now please note that all those had a du dx. Why?
Chain rule.
Thank you. Chain rule. It's not x sitting there. It does not say sine x. It says sine u. Because it says sine u, you had to have sine u times du dx. Not a point on x. You need to have the derivative of that function. The first one is u n to the u n u to the n minus 1. By the way, what is that? Thank you. That's power rule. So let's talk about integrating then. Hey, I know how to integrate u to the nth. That makes what? How do I integrate u to the nth? How do I integrate u to the nth?
Oh, u plus 1 over n plus 1. Plus 1.
Just like we've been integrating u to the n plus 1 over n plus 1. That hasn't changed. That's still the same integration that we did. Hey, isn't it that that's the antiderivative of integration of antiderivative of u to the n? Okay. Isn't it going backwards from u to the n? So integrating and then integrating going backwards. Okay. So I actually want to start now. I've given them to you, but I want to start down here at cosine. The integration of cosine is sine. Want to know why? What's the derivative of sine? Sine. Cosine. The integration of sine is negative cosine. Want to know why? What's the derivative of cosine? Hey, wouldn't that negative cancel out that negative? The integration of secant squared is tangent. Want to know why? What's the derivative of tangent? Secant squared. The integration of secant tangent is just secant. Want to know why? What's the derivative of secant? Secant tangent. The integration of cosecant cotangent is negative cosecant, because remember that has the negative on it. This didn't, so negative goes on the integration. And the integration of cosecant squared is negative cotangent. All those have plus c's on them, and they have the u's on them. So here's how I will always do mine, because I always check mine, because I script the signs all the time on this, S-I-G-N-S, the positive, negative. So I always say, okay, I think this is the derivative. I think this is the integration. If I take the derivative, do I match? I do that all the time when I'm doing trig. I do that all the time to make sure my signs are correct, make sure I've done it correctly. This is the integration. Okay, I think that's right. If I take the derivative, do I get what I started with? If I do, then I'm good. A reminder, remember how I had this last time? If I had 2 positives and 2 negatives, and then the positive again, sine, cosine, negative cosine, sine. Differentiate, you go down. If you integrate, you go up. The integration of sine is negative cosine. The integration of negative cosine is negative sine. The integration of negative sine is cosine. The integration of cosine is sine. So if that makes sense to you, great. You can use it. If it doesn't make sense to you, then don't worry about it. Okay? And just memorize. I don't care how you do it. That is literally your choice of how you decide to memorize things.
All that like nice.
So my first example says the integration. This is on the bottom of your paper. So you can probably put it on the bottom of the paper, but I know that the next page won't be able to fit. So it's up to you where you put them. Or just put them on your other piece of paper. Number 1 says integration of 4 cosecant cotangent x minus 3 cosecant squared x plus 6 dx. I'm going to talk about this, and I'm going to split this up, because I can. Now, why can I split this up into 3 separate pieces? Why can I split this up into 3 separate pieces? Nope.
No,
Because what's this between all of these? Addition and subtraction. That's why I can split it up. Not because if it was. Can I split up the cosecant x cotangent x?
No.
No, why? Because they're being
Multiple.
multiplied. You can't split up something that's being multiplied. You can't integrate separately something that's being multiplied. You only can integrate separately things that are being added and subtracted. It's just like we did for product rule for polynomials and stuff. Same rules apply. All right, so I integrate. What do I do with this 4 though?
Leave it up.
Take it out. Please only can sit outside. Because it's a constant, right? Can you integrate cosecant cotangent? What's that give you?
Negative. No, wait, no. Yeah. No, negative cosecant, sorry.
We're going to agree with Merlot. Negative cosecant.
Yeah.
Because what's the derivative of cosecant? Negative cotangent cosecant. Everyone agrees with what I've written? Ooh, Jenna, what? Do parentheses make a difference here? Where do they need to go?
After or in.
Those parentheses make a huge difference, so please make sure they're there. Because if you don't have them, that becomes 4 minus, not 4 times. Can I integrate this piece? The next piece says negative 3 cosecant squared x dx. Huh? I can take out the negative 3. If I take out the negative 3, hey, by the way, could I have left the negative sign with that
No.
and just said that I recognize? Could I have left the negative with the cosecant squared and gotten a positive cotangent?
Yes.
Yes. Or you do it this way. It doesn't matter, you get out the exact same answer. Since I already wrote this in black, I'm going to break this one down. And I have one more piece, the integration of 6. Everyone agree with my answer? Why not? Now you agree with my answer.
Yes.
There we go. That's the integration of negative 4 cosecant cotangent minus 3 cosecant squared plus 6 is negative 4 cosecant x plus 3 cotangent x plus 6x plus c. Let's talk about number 2. It says negative 2 cosine x over 3.
Oh, wow. Technology.
Gabriel, what do you want to do first? Fabulous. Why? I'd say what? What is? Yep. It's a constant being multiplied, so I can take it out. It's a constant being multiplied, so I can take it out. Is that a plus or minus? That would be an issue, but it's not. If it was adding or subtracting, that would be an issue. Can I integrate this now? Let's see. You integrate cosine x. What do you get? Alright. And I always check myself. The derivative of sine is cosine. I'm good. And am I done? Here we go. Negative 2/3 cosine of negative 2/3 sine x plus c. The derivative of sine is cosine, so I'm good. Alright, flip it over. We have 3 more problems to do. 3. Three, 4, and 5. I want you to try number 3. I want to chat a bit about a couple things that I see. I see this a lot. By the way, you realize that this is the same thing as this? I have a lot of you that I saw on your paper, you brought up the cosine x and made it a negative 1, but you need to recognize that that's the same thing as cosine x to the negative 2 power. Is everyone okay with that? when you do this, then what are you planning on using?
Oh, U sub.
U sub. You got a quantity with a parentheses. I would plan on using U sub. Let U equal what?
Cosine.
Then du.
Sine. Oh no, negative sine.
Here's my question. Do I have sine x over there?
You got 5 out of that.
No. That's an issue. Because the derivative, or at least the variable portion of the derivative, has to be there. That portion, which is the sine x, is not over there. So can you use U substitution for this? So U substitution doesn't work for this problem. So I'm going to go back to this. And Abby, will you tell me what you did, please? I'm good with that. Oh, thank you, Abby. Abby recognized that 1 over cosine squared is the same thing as secant squared. Oh, and then what did you do next? There will be times that you have to do U substitution. We're going to talk about that next class. You know how to do U substitutions. It's not really anything new, which is using a trig. But this is not the case where you use U substitution, because you don't have the pieces that you need to use U substitution. This is the case where I'm just rewriting it, manipulating it. Alright. So I want you to try number 4. Yes. Which ones?
The ones where it's like sine x squared is cosine x squared equals 1 and then 2. Is that what it is?
Yeah.
1 minus sine
You're on number 4. Hopefully you recognize that 1 minus sine squared is cosine squared.
Yep.
And I had some people that moved it up and just sine squared times sine times cosine times secant squared, but that doesn't give you anything. So I thought of it a different way. I thought it in terms of cosine squared is cosine times cosine. So I wrote it as cosine times cosine. Well, then I saw, sine over cosine I know. And it's a 1 over cosine left over. Notice that again, this is a manipulation of what you have. This was a manipulation of what you have in order to work this. Okay. By the way, you could do this one. You could do this one by U substitution. This is one that you could do by U substitution, like U equal cosine, because I have sine there. If you want me to show you that one, I will. Actually, you know what? I'm going to do that. Yeah, I'm going to take 2 minutes to do that. I want to show you real quick that this one can be done. I'm going to start here. So I'm going to show you how this will look like for U substitution. I'm going to show you how this one would look for U substitution. Because you have a cosine squared on the bottom. That's your quantity squared. Let U equal what? Let U equal what? Okay? Then what's du? Do I have that?
Sort of.
I sort of do. The only thing I'm missing is what?
Negative.
So that would give me the integration of 1 over u squared du over negative 1, or negative the integration of u to the negative 2 du. Can you integrate this?
Yes.
What's the integration of u to the negative 2? What happens to those negative signs?
Cancel out.
What was u again? What's 1 over cosine? Hey, isn't that the same answer that we got? Look at that. Different way of doing it, got the exact same answer. Yes. Yep. Is that better? So, again, that's a kind of a preview for next class. But u substitution, you know how to do u substitution. We've done that last unit. Now it's just with signs. And again, if you're doing with signs, if I'm talking about the derivative, if sine is what u is, then cosine has to be there somewhere. Cosine has to be there for the dx. If I'm talking about the derivative of tangent, secant squared has to be there. If it's not there, then I can't use u substitution if I say let u equal tangent. All right, one last one. Where'd my one last one go? Maybe it's not input on here. All right. So your last one's on there. What's the first step on the last one? What's the first step you're going to do?
Integrate.
Integrate. Fine. And which gives you the what?
First derivative.
All right. Omar, if I integrate sine of x. Omar, what do you get? Plus c. So the derivative of negative cosine is sine, so we're good there. I do agree with that. Now what's next?
Plug in pi.
Okay. Because I tell you f prime of pi is 2. So 2 equals negative cosine of pi plus c. What's the cosine of pi?
Negative.
I remember when I said last class, you need to know your unit circle, or the class before last, you need to know your unit circle, you need to know the unit circle, you need to know the unit circle. Yeah. You need to know your unit circle. So let's see here. So now I have f prime of x equals negative cosine x plus 1. Do it again. So I'm going to make violet. What's the integration of negative cosine x? Fabulous. Lauren, what's the integration of 1? And we're going to have our plus c. And I tell you this time that f of pi is what? 2, I think?
Negative 1.
Negative 1. Negative 1 equals negative sine pi plus 1 times pi plus c. Jason, sine of pi.
Sure.
Emma, c equals? Final step. f of x. Negative sine x plus x minus 1 minus pi. There's my fun words. All right.